Hello everyone, George here, and we're back in OpenCV. We've done most of the basics at this point. I think it would be far more beneficial to all of you if we just jumped ahead and we went to straight webcam monitoring with the Aruco markers. So I've gone ahead and printed out two of those markers. Let's see, this one and this one right here. In this video, what we're going to do is program the function which will continually monitor a live webcam that is able to find these Aruco markers and then determine basically the translation and rotation, offset, and world scale that object would be at. And once you have this information, if you're using other programs like OpenGL or anything else, DirectX, you can then take 3D models and other things and place them on top of it. So within our main CPP file, why don't we go ahead and make this? We're going to call this start webcam monitoring, because that's what this one's going to be doing. It's going to be monitoring information from a webcam. What it will do is return to us an integer value. Why? Well, if something fails, I'm going to return a negative value, like if I couldn't find a webcam, and if things are great, I'm going to return a 1, indicating that, hey, all's good until we exit out. So let's add an int as our return type. We're going to need a few variables right at the front. If you've been doing the webcam stuff with me so far, you know that we need a mat frame object that's going to hold the frame of information from our webcam. And that's the frame we're going to be analyzing to see whether or not an Aruco marker is actually visible. This video is assuming you've been following through with the past videos and you've already created a camera matrix. We're going to need 3 more things to help us on out. The first is the fact that we need to know what our marker IDs are. We need a vector of those objects, and it's going to be a series of integers. So let's do vector, int, and marker IDs. Then what we're going to need is, once again, a vector of vectors of points. And those are going to end up being our marker corners, the corners of the marker that are being detected. So let's do vector of vectors. And now let's do point 2f. It's a point 2f because once again we're dealing with the 2-dimensional value we get from an image. We're not in a 3D world yet. And let's do marker corners. And let's do rejected candidates. Wonderful. I forgot one of my greater than symbols. There we go. Now is when we get to the Aruco part. If you are using basic OpenCV at this point because you've skipped ahead in the video series, you need to go back 5 or 6 videos where I show you how to compile your own version of OpenCV that uses the contribute libraries, specifically the Aruco libraries, which is what we're using here. So let's do Aruco : because that's the namespace, and we're going to do a detector parameters, and we're just going to call those parameters. The name pretty much explains it. It's the parameters that we're going to be using for detection. We actually need to make sure we're working with the same dictionary of Aruco markers. If you remember back a few videos, I showed you how to generate your own Aruco markers, and there were many different types you could do. You could do ones that were of size 50, 100, and so forth, and 6x6 and 8x8. And depending upon which one you use, you got to make sure you're going to be trying to detect the same ones. Once again, we're going to need to deal with pointer objects, and we're going to deal with the Aruco : dictionary object. And we're going to call that a marker dictionary. And we now need to actually get this predefined dictionary for us. By the way, you don't have to use the predefined dictionaries. You can actually create your own dictionaries. If you go into the documentation, it'll explain how you can do this yourself. But for 99% of the cases, unless you're doing something incredibly different, these markers are perfect to work with, especially for a beginning tutorial. So let's do Aruco : get predefined dictionary. And we're going to grab the Aruco. Once again, more namespaces. I probably should have just included that, but I really didn't want to deal with name clashing. And let's do predefined dictionary name : and dict underscore 4 by 4 underscore, and I went for the 50 markers. I went for the smallest dictionary size and the smallest number of markers. The reason for this is because if you read the documentation, the more markers you add, basically the more work the computer has to do to determine whether or not it's the proper marker. 4 by 4 is the smallest, 50 is also the smallest subset. I don't need more than 50 markers. Now is where we get to the point that you should all be familiar with if you've been watching my entire video tutorial series. We're going to grab our video capture webcam source, check if it's open, give it a name, open up a window, and continually loop over that window, constantly looking for these Aruco markers. So let's go ahead and begin. First, we need to grab our video capture area. We're going to be pulling from not video 0, as you will be doing, but because of my setup and the fact that I have capture software and hardware that automatically grab the first camera attached to it, I have to grab from source 1 because I have 2 webcams set up. So let's do this. Remember, video capture, you will be putting a 0 most likely. I'm going to have to put a 1 down because of my setup. Next up, of course, we need to see whether or not we even grabbed the darn thing, because if we didn't grab the thing, then, well, something failed miserably, your webcam didn't work, something else is actually taking control of it, although I have noticed that if something else actually does take control of your webcam, it still tries to access it and works, it just provides you with no information whatsoever. So let's do a return -1, there we are. It would be happy if I actually put a variable there. There we go. So vid, if vid has not been opened, return -1 and get out of here because we can't monitor the webcam. Same stuff as usual. We got to make a window so we can see the output. So let's do a named window. We're going to call the same thing we've always been calling it. I'm going to do webcam. And we're going to do a CV underscore window auto size. If you don't know what this is, please continue to go back to the previous tutorials that I put out there. So now we need a GUI window that's going to pop up. We're going to do this named window. Oh, this is not my morning for typing, apparently. And inside of that, we got to specify the name. The name is very important. If you haven't watched before, the name is basically how you can relate back to that window. And we'll do CV underscore window underscore auto size. Great for them. So let's do a vector, and it's going to be a vec 3D. Why? Because we're actually starting to deal with the three-dimensional world. We're no longer just dealing with these images and vectors. There we go. Now's the big old loop. This is the one that continually pulls over and over and over again, trying to find those Aruco markers. It's the same thing as the webcam stuff we did before, so let's do a while true. You can make this not true if you want to. Maybe you want some sort of an escape condition. Maybe something fails. Maybe you want a timer. It doesn't matter to me. I'm going to do escape true if we are unable to read a frame from the video. We're going to get the heck out of this loop because I don't want it to persist forever. Break. There you go. Okay, now we're getting to some Aruco stuff. So we're going to do Aruco : for that namespace, and we want to call the function detect markers. This is the one that's going to find the stuff for us. We're going to pass in the frame, obviously, because, you know, if it doesn't have an image with an Aruco marker in it, we're not going to do much anyway, right? And then we need to also pass in our marker dictionary. Why is that important? Because those are the markers that it's trying to find. Remember, if you put in a different marker dictionary than the one you're working with, there's no chance in hell of this finding anything. Now we need to pass in our marker corners because those are the corners that we want to detect, and then of course our marker IDs. What are the marker IDs? Well, let's jump back over here. These are the marker IDs, okay? We got 0 all the way up through 49, which are 50 different potential IDs. That is how Aruco is going to be able to know what IDs are there and ultimately how to differentiate them. Next up, we need to estimate the pose. Aruco : estimate suppose single markers because they're each single. There are other ways of doing this, by the way, that I'm not covering. You could have a single piece of paper with multiple Aruco markers on them. We're going to do one by one for my case. We need to pass in those marker corners. We also need to pass in our Aruco square dimensions, which we did in a previous video where you take a ruler or a caliper to them and measure the actual size of the Aruco marker. And I'm not talking about the size of the paper, I'm talking about the size of the Aruco marker that was actually printed on the paper. Since it's a square, all the sides should be the same. Next up, hopefully at this point, you've taken the time to create a camera matrix. Not a calibration square dimension, but a camera matrix. I'm going to warn you right now, sometimes your camera matrices are crap. I think when the first time I did this, I ran through maybe 10 or 12 different trials trying to find out why my camera matrix just would not get the z-axis right. And ultimately, it was because I was not getting close enough, rotating enough, putting it at an angle, and then getting really far away and doing the same thing at angles. So please, when you're doing your camera calibration, don't stick to 10 or 15. Usually the best results I get are when they're 20 or more. And really, in some of the better cases, I went all the way to 50 different camera values, get the best image I possibly can. Don't be afraid of overcompensating for your calibration matrix. It's just going to make stuff better. Next up, we need things like the distance coefficients, which we talked about last time. I got to take a step back now because I never actually filled in the parameters for what the start webcam monitoring deals with. And those parameters now are going to be incredibly important for us to fill in the Aruco stuff so that we can actually find stuff. So let's do that now. Of course, what's the most important thing? Why have we been laboring for videos and videos and videos on this? We need that mat object. It's got to be a reference because why not? Actually, you know what? We're not messing with it. Technically, it can be a constant reference. And we need to do camera matrix. Next up, we need those distance coefficients. So let's do another constant mat ampersand for reference and distance coefficients. Remember to put that E in there. Proper spelling is important. And last thing we need, of course, is that Aruco marker dimension. That's the one you were supposed to already have measured yourselves after you printed these markers out on a piece of paper. So float Aruco dimensions. Aruco square dimensions. Great. And now we can actually start filling this stuff in. We've given it our marker corners, the square dimensions. Now we need to give it that camera matrix. Then the distance coefficients, which we just added. And then, of course, our rotation vectors and our translation vectors. Literally, we're almost done. We're going to create a for loop within this while loop. And all that's going to do is continually draw the axis of the Aruco marker that we detect on top of the image frame that we have. So let's do Aruco draw axis. Now what does this need? First of all, if you're going to draw something, you need the frame. Next up, we need the camera matrix, which we've labored over, and I'm sorry we have for several videos getting that ready. Next up, we need the distance coefficients, and it's going to require our rotation and translation vectors. Alright, so what's up next? We need to do a for loop because we have lots of different markers that could potentially be in the image. We need to make sure we iterate over all potential images and see whether or not they're found and validated. So let's do a for loop for, and And within the for loop, you're going to expect this normal stuff. Int I is equal to 0. I is going to be less than the marker IDs dot size, because that's how many different marker IDs we actually have to work with. And then finally, the last bit we're going to deal with is I++. So now that we have that information, everything gets incredibly simple. Literally, we have only about 3 or 4 lines of code left before we're done. So let's do Aruco, : draw axis. That's going to draw the axis onto the image that we have. And then we're going to do the frame. Why? Because if we're drawing something, we need the actual image. We're going to pass in the camera matrix, because that's key to just about everything we've done. That's why this video series has been so darn long, and I'm sure so many of you have been annoyed by the fact that I have not finished this yet. And I'm sorry about that, but I'm trying, guys, okay? Next up, we're going to need to put in those rotation vectors that we have right up here. And then, of course, our translation vectors as well. And the last thing we have to put in is our length, which I'm going to set as 0.1f. Okay, guys, we now have a loop that continually goes over our webcam. It looks for those Aruco markers, and if we're lucky and we find one, it's going to draw that axis to the object. Next up, we need to show this stuff on the screen, because I'm sure a lot of you guys are not only hobbyists, but college students who have decided for some reason to take on this as a project and realize there's almost no resources for it. So let's do an I am show. And by the way, I was in your shoes years ago at the same time, but somehow I beasted through it, figured it all out, and made a pretty kick-ass project where drones were able to figure out where they were within a drone cage. But that's a whole other story. Now we're going to do the whole if wait key. We're going to do 30 milliseconds. 30 is greater than or equal to our 0. Then we're just going to break out of this thing. Basically, if we don't get any more information within that time frame, we're done, and you screwed something up. And finally, remember, we did a return value up here, return int. Let's jump on down here, and let's do a return 1. Meaning we succeeded in doing most of what we wanted to do. This stuff might have failed, but ultimately we were able to open up a video line and try to do some stuff and get to where we wanted to. So how do we work with this? Well, there's a lot of ways. We can use the command line when we enter into the function to choose whether or not we want to just start webcam monitoring and we have a camera matrix already set up. Instead, what I'm probably going to do for this video is I'm just going to replace my main function here with, actually I'm going to copy out all of this stuff before with camera calibration, put it in a different function, and then calibrate it as best I can at home. Once again, I'm at home, I don't have a lot of room, and I have a really crap webcam, but I'm going to do that first. I'm going to calibrate off camera so you don't have to deal with it, and then hopefully you will all see what happens when I decide to call our start webcam monitoring after I have my own camera matrix. And I'm going to see you in the next video where we actually show the outcome of all of this. Sorry to break it up into a second video. I'm really not trying to make this super long. It's just, this is as much time as I have right now to make something for you guys to work with, okay? So anyway, once again, I hope you enjoyed it. If you liked it, liked it. If you didn't like it, don't only dislike it, let me know what I did wrong so I can improve in the future. And if you want more material like this, I very much appreciate that you subscribe to my channel. We're going to be doing, oh geez, so many more projects in the future. It's going to be a lot, guys. And have a great day, have a great night, have a great evening, wherever you are in the world. Because from my YouTube statistics, it seems like I've got people from just about every corner of this planet listening in. And I thank you for wanting this material and enjoying it. See you next time, everyone. Goodbye.